Okay, so good day, grade 8 max sci students. So let's explore the concept of a Pythagorean triple. A Pythagorean triple is a set of three positive integers such that the set of numbers signifies the side measurements of a right triangle. And it means that it's a perfect, there are three sets of numbers that are perfect whole numbers. Okay, they are perfect whole numbers that satisfy the equation of the Pythagorean theorem. Okay, let's say for example, we have here the first 16 set of Pythagorean triples. So we call them as the primitive Pythagorean triples. Okay, so they're called primitive because they are the first 16. Okay, the first 16 Pythagorean triples, and all of them are less than 100. Okay, so that's why they are called the primitive Pythagorean triples. Okay, let's just check. Let's just check if they are some of the Pythagorean triples. Okay, so let's try to check this one. Okay, just a random one. Okay, so we have here a squared plus b squared is equal to c squared. Well, where a and b are the side or the legs of the right triangle. So if we have here 16, 63, and 65, so a must be 16 and b must be 63, and of course the hypotenuse c must be 65. So we have here 16 squared plus 63 squared is equal to 65. Okay, 65 squared, and let's check whether that's correct. So 16 squared, so that's 256. Okay, 256 plus 63 squared, so that's going to be 3,969 is equal to 65 squared, which is equal to 4,225. And true enough, if we add 256 from if we add 256 to 3,969, we're going to get 4,225 on both sides. There you go. So therefore, this is a Pythagorean triple. Okay, and you can also try some of the other 15 Pythagorean triple sets that we have here. Okay, but most likely, 100% that all of these number sets here are Pythagorean triples. The simplest of which is 3, 4, 5. Okay, so we have the 3, 4, 5 right triangle. Okay, so 3, 4, and the hypotenuse is 5. And sure enough, 3 squared, which is 9, that's the one that we saw a while ago, plus 4 squared, 16, will give you 5 squared, which is equal to 25. Okay, and also if we try to visualize the Pythagorean triple, so they kind of look like this. So it's kind of like a pattern. Okay, so this is the pattern of the Pythagorean triples. So these dots represent all of the numbers, or all of the sets of numbers that follow the Pythagorean triples. So it was mapped using a computer, and this was the pattern that was created. So it kind of looks like rays of a sun, right? Kind of looks like the rays of a rising sun. So there you go. So the beauty of mathematics can be seen when you deal with big data. So there you go. So we have the beauty of mathematics reflected here by the Pythagorean triples on the first quadrant of a Cartesian coordinate plane system. So there you go. Okay, so this is the map. Okay, this is the map of the Pythagorean triples. And of course, the Pythagorean triples, since the numbers are infinite, then the Pythagorean triples are also infinite in nature. Okay, so they extend without end, and this pattern repeats itself throughout infinity. Okay, so the Pythagoras of Samos, so like hero of Alexandria, Pythagoras of Samos has a history. Pythagoras of Samos was one of the first Greek philosophers of the ancient times. He was an Ionian Greek philosopher and the founder of Pythagoreanism. Pythagoreanism. Okay, so since he founded an academy in Greece, so from his academy he taught different subjects, but mostly it's focused on music theory. So the time signatures that we follow in music, so it has its origins in Pythagorean theorem and also in the teachings of Pythagoras. And also the Pythagoreans believed that geometry is the highest form of mathematics and that nature and reality can only be understood through geometry. So for them, the basic of mathematics was not arithmetic, but it's geometry. Okay, so following the death of Pythagoras, so there were two schools that were created by his students. So there were the mathematikoi and the acousmatikoi. So the acousmatikoi were more likely the religious part of the academy, wherein they follow the religious teachings of Pythagoras. Okay, so keeping alive the oral traditions and through oral discussions. So there you go. So that's why they're called acousmatikoi, from the word acoustics. And then we have the mathematikoi. So they developed the intellectual rigor, okay, of the teachings of Pythagoras. So they developed more of the mathematics sides of the teachings of Pythagoras, as well as a continuation of his teachings in music theory as well. Okay, so let's try to solve some problems involving the areas of triangles and also applying the Pythagorean theorem to some of these problems. Okay, so we have here Zeke wants to build a playground, okay, for his dogs in the shape of a triangle. Given that the playground has a base, okay, of s plus 7 meters, okay, and the area is equal to 250 meters squared. Find the measurement of the height of the triangular playground if it's equal to, okay, so if h is equal to s plus 1 meter. So from this problem right ahead, we need to solve for the value of s. Okay, so how can we solve for the value of s? Let us use the area of a triangle. Okay, so the area of a triangle, which is equal to 250 squared meters, is going to be equal to 1/2. Okay, base. Okay, so what's the value of our base? Is equal to s plus 7, and then our height is equal to s plus 1. Okay, and from here we can solve. Okay, we can solve for the value of s by multiplying the entire equation by 2. Okay, so therefore we have here 500 is equal to 2. Oh no, is equal to s plus 7. Okay, so s plus 7 times s plus 1, so this is going to give you s squared. Okay, and then 7s plus 1s will give you 8s plus 7. And therefore we have here a quadratic equation, s squared plus 8s, and then okay, plus 7, and then minus 500, so that's going to give you negative 493. And using our calculator or using calculators from the internet in solving for quadratic equation, for the roots of quadratic equations, okay, so we have your calculator. If you try to remember how to use it, okay, so we have your mode. We're going to do it again. So mode, and then let's press 5 equation, and then free. Okay, free for quadratic equation. So we're going to write the numerical coefficients. So we have here 1, 8, and negative 493. Okay, so 1, 8, and then negative 493. Okay, so that's going to give us the value of the first root is equal to, okay, so s sub 1 is equal to 18.56, and s sub 2 is equal to negative 26.56. Okay, so since we cannot take the value of a negative number, therefore we cannot use this one. We will use the first root, which is 18.56, and therefore the value of the height, okay, the height is equal to s plus 1 meters, therefore the height is equal to 18.56 plus 1, so it's going to give you 19.56 meters. So therefore the height of this triangle is equal to 19.56 meters. Okay, so for our second problem, we have here Armin wants to create a library about oceans and seas. Given that he drew a 2D schematic of the floor plan for the library in the shape of a triangle, find its area given that the measurements of the sides F. Okay, so side F is this one. Okay, so this is LY. So side F measures 5 meters, and side L, so side L is Fy, so this one. So side L is equal to 12 meters, and we have here an angle FYL is 52 degrees. So we want to, or angle Y is equal to 52 degrees, we want to get the area of this entire triangle. So to solve for the area, since we're only given two angles, and we're given, we're given two sides. Okay, we're given two side measurements. We're given two side measurements and we're given only one angle. Then we can use the first sine function formula for finding the area of the triangle. Okay, so it's given by this formula right here. Okay, so we have here A is equal to 1/2 A times B. Okay, A times B sine C. Okay, so therefore, to solve for the area, we simply have to plug in the numbers or the given information that we have. So this is going to give us A is equal to 1/2 times 12 and then times 5. Okay. Okay, times 5 sine C, and our sine C is going to be 52. So if you notice, B sine C here is actually the height of the, okay, it's the height of the of what they call this, of our given triangle here. So A is the base. Okay, there you go. So we can now solve for the area. So this will give us 60 all over 2 multiplied by sine 52. So therefore the area is equal to 30 sine 52. And what's 30 sine 52? Okay, so 30 sine 52 is equal to 23.64. Okay, 23.64 squared meters. Okay, so therefore, the area of the library that Armin would need to build will be 23.64 squared meters. Okay, let's try some third problem. The third problem. Aaron wants to create a free aerial garden for his friends and family. The floating garden has a base of the base of a triangle. Given that one of the sides of the triangular base of the garden measures 148 centimeters and the two angles, angle G and O, measure 23 and 59 degrees, find the area of the hanging triangular flower garden. Okay, so we're going to use for this third problem, we're going to use the second sine formula. Again, what is the formula for the second sine function? So that's going to give us A is equal to A squared sine B times sine C all over 2 times sine quantity B plus C. Okay, so there you go. So we have here the one of the side measurements, A, is equal to 148. Okay, 148 centimeters. And we have another angle here, angle O. We have an angle O is 59 degrees, and angle G is equal to 23 degrees. And we want to know the area of the aerial garden of Aaron. Okay, so the area of the triangle GRO, O or RG. Okay, so to solve for that, we have here A squared is equal to 148 squared. Okay, so this one should be sine O. Okay, so essentially, if we're going to use the degrees, if we're going to use the given information, sine O and then sine G. Okay, so this is sine O plus G. So this will give us sine O, which is equal to sine 59, okay, multiplied by sine 23 all over 2. Okay, all over 2 times sine, okay, 59 plus 23. Okay, so let's try to solve for this one. 148 squared, so that'll give us 21,904. Okay, so that'll give us sine 59 sine 23 all over 2. Okay, so 59 plus 23, so that's going to give us sine 82. Sine 82. And therefore, the answer for this one is going to be equal to... Okay, so after having computed it on a calculator, we can say that the area is equal to 3,704.11 squared centimeters. Okay, so there you go. That's the area. 3,704.11 squared.